Let's talk about a piece of technology that you've probably never heard of, but it is absolutely essential for making all of our electronics smaller, faster, and way more powerful. It's called Active EMI Filtering. And believe me, it's a brilliant fix for a problem that's been bugging our gadgets for years.
So think about your phone charger for a second, or maybe your laptop's power adapter. If you had to pick just one thing inside to shrink down to make the whole device smaller, what would you choose? The processor? The memory chips? What do you think it is?
Yeah, the answer is probably not what you're thinking. If you crack open a modern power supply, like you see here, some of the biggest space hogs are these chunky copper wound things. These are called EMI filters, and they've actually become a huge roadblock in the mission to shrink our electronics.
And that right there brings us to this really fundamental challenge in electronics today. It's a big, big problem caused by something happening incredibly fast at a tiny scale. So let's break this down.
Okay, so every modern power converter, the thing that charges your phone, your laptop, everything, it works by switching electricity on and off at insane speeds. Now, this makes them super efficient, but there's a catch. It creates a ton of high-frequency electrical noise. We call this electromagnetic interference, or EMI. You can think of it like electrical static that can mess with the device itself or even other gadgets nearby. So, for decades, the way we've dealt with this noise problem has basically been brute force. Engineers use what are called passive filters. And these are those big inductors and capacitors we saw earlier, those chunky parts that literally act like a physical wall to block the noise from escaping.
And this quote just nails the problem perfectly. As our microchips and processors kept shrinking year after year, these filters, they just stayed big. They can eat up a third of the space on a circuit board. This created a massive bottleneck, holding back how small and powerful we could make things.
So what we've got here is a classic tech showdown. You've got the old way, passive filters, a brute force solution that blocks noise but is big and heavy. And on the other side, you've got this new intelligent innovation, active filters. They're compact, they're light, and they do something completely different. They don't block the noise at all.
So let's look at this smarter way of dealing with all that electrical noise. This is where the whole approach just flips on its head.
The big idea is this. Instead of trying to build a bigger, stronger wall to block the noise, what if you could just make the noise vanish? The real breakthrough isn't blocking it, it's actively canceling it out. And honestly, the best way to get this is an analogy we all know. Noise-canceling headphones, right? They don't just plug your ears to block sound. They listen to the noise around you and then create an opposite sound wave to completely cancel it out. Well, active EMI filters do the exact same thing, just for electrical noise.
Okay, so that sounds cool, but how does this electronic noise cancellation actually work? Well, the principle behind it is surprisingly simple and kind of beautiful.
It all happens in 3 quick steps. First, a sensing circuit listens to the electrical line to identify the exact noise it needs to get rid of. Second, an amplifier instantly creates a perfect mirror image of that noise. We call it anti-noise. And finally, step 3, it injects that anti-noise back into the circuit. The two opposite waves meet and poof, they completely annihilate each other, leaving nothing but clean power. Now, one of the really common ways engineers actually build these is a method called voltage sensing current compensation. It basically uses tiny capacitors to hear the noise voltage, and then an amplifier injects the canceling current. And the coolest part is that this whole active circuit acts like a virtual capacitor that's way, way more powerful than its physical size would suggest. It's all the power without the bulk.
So that's the theory. But what does this look like in the real world? This is where it gets really impressive. Let's take a look at the results. I mean, this image just says it all, doesn't it? On the right, you have that traditional bulky component from an old-school passive filter. And on the left, that tiny little circuit board. That is the active filter that replaces it. This isn't just a small improvement. It's a completely different scale.
Let's put a hard number on it. In one study on a 1,000-watt power supply, swapping to an active filter cut the volume of the filtering parts by 90.3%. 90%! That is an unbelievable amount of space to get back.
And this table here shows you exactly how they did it. Look at that original column. You've got 3 of these bulky chokes taking up over 32 cubic centimeters. Now look at the column with active filter. They're just Gone, removed, replaced by that tiny active circuit, freeing up all that precious internal real estate. So, shrinking a filter is cool engineering, for sure, but what does this actually mean for the tech we use every day? Let's talk about why this really matters. Well, this is the tech that lets us have smaller, faster charging laptop adapters that don't feel like you're carrying a brick. It's absolutely critical for making electric vehicle power systems lighter and more efficient, which can help extend their range. We're seeing it in solar inverters, in advanced motors, and even in systems that protect delicate parts, like motor bearings, from being damaged by all that electrical noise. So here's the big takeaway. This isn't just about making our gadgets smaller for the sake of it. It's about a concept called power density, and that's pretty much the holy grail of electronics. How do you get more power from a smaller space with less weight and less wasted energy? Active filtering is one of the key things unlocking that next generation of technology. It really makes you think, doesn't it? We solved a physical space problem, not with a bigger physical object, but with an intelligent, active circuit that just sidestepped the problem entirely. As our world gets more and more electrified, you've got to wonder, what other invisible roadblocks are out there, just waiting for a smart, active solution to make them disappear?